solving equations involving absolute value day 1. We need to do a little review with absolute value. Remember, absolute value is the number's distance from 0 on a number line. The notation for absolute value would be something like this. This is saying the absolute value of -5. This is saying the absolute value of 5. That is the distance from 0. So how many units away it is on a number line, it would look like this. So -5 would be 5 units from 0. So the absolute value of -5 is 5. Same here. 5 is 5 units from 0. So the absolute value of 5 is 5. The next couple of problems should be a little bit of review. It says evaluate, so we need to solve. In order to solve this, we need to substitute in accordingly, and we know that m in example 1 is 4. So I'm going to go ahead and substitute in. The red there is my substitution taking place. I like to use a set of parentheses to show that I substituted in for m. Your absolute value sign acts as a set of parentheses. So basically, you need to solve what's inside your absolute value first. 4 plus 6 is 10, so we have absolute value of 10, and then we have this minus 14. Well, the absolute value of 10 is 10, so we have 10 minus 14. 10 minus 14 is going to give us -4 here for example number 1. Example 2, same scenario. Go ahead, rewrite the expression, substitute 2 in for x, use a set of parentheses to show that substitution is taking place. There's my substitution. Reminder, we need to go ahead and take care of what's inside the parentheses first, following order of operations. So I'm going to go ahead and just rewrite things as we go here. 23 take away 2 inside my absolute value. Inside the absolute value, you take care of multiplication before your subtraction. So I actually have 3, and then we have 4 times 2 is going to give us 8, and that is -8. Order of operation, PEMDAS. Next, go ahead and solve what's inside your set of parentheses, because again, or I should say absolute value, because it's acting like a set of parentheses. So we have 23 minus 2, and then we have inside here 3 minus 8 is -5. Keep working down our paper here. We have 23, we have -2. The absolute value of -5 is 5. So now it'll turn into multiplication here. Order of operations. Take care of the multiplication before subtraction. So we have 2 times 5 is 10. We have 23 take away 10, and this will give us 13. When solving equations here, the key concept is a big piece of the pie here. When solving absolute value equations, there are 2 cases to consider. 2 cases. Here's both cases. Case 1, the expression inside the absolute value is positive, and it is also negative. Take this for instance. We have the absolute value of x equals 10. 10 can be substituted in for x because the absolute value of 10 is 10. So that is a true statement. Also, x can also be -10. If you put in -10 for x, the absolute value of -10 equals 10 because it's 10 units from 0. So when you come to these equations, in example 1 says solve each equation, then graph the solution set, you need to come up with both scenarios. The way to do that is to get rid of your absolute value sign. So I write it as f equals 17, and the second scenario, being negative, is f equals -17. So in this problem, your answer is 17 and -17. Both can be put in for f to make this a true statement. Now you need to go ahead and graph this set on a number line. Here's my number line. I'm going to go ahead and graph my solutions. My 2 solutions are 17 that we figured out and -17. So there would be my plots on my number line. Example 2, a little more difficult. Not too bad though. 2 cases. So go ahead and write out both cases. Get rid of the absolute value sign. So we have x plus 5 equals positive 17. And we have the second scenario where x plus 5 equals -17. So you're just changing that, make sure that one's positive, one negative, and then we go ahead and solve the equation. So we have 2 equations that we need to solve here. We need to subtract by 5 on this side. we also need to subtract by 5 on this side. We find out x equals 17 take away 5 is 12, and x equals negative 17 take away 5 is negative 22. So my two answers here are 12 and negative 22, which I need to graph on a number line. Number line's going up by tens here, so 12's a slightly ahead of 10 here. So I'm going to put a plot, and negative 22 is slightly after 20. There's my two plots. There it is on a number line. The next thing they're just asking us to do is to check. Here's how you would check your answer. Well, you substitute back into your two cases. So start with your original equation, which is absolute value x plus 5 equals 17. Plug both of these in to check to see if they work. Well, here's case 1. 12 was a potential answer, so I put in 12 for x. 12 plus 5 is 17. So I have the absolute value of 17 equals 17, which is 17 equals 17. So this would check out. Second option that we had, well, we also had negative 22 as an answer. So I put in negative 22 for x. Same thing here. Negative 22 plus 5 is going to give me negative 17. Well, absolute value of negative 17 would equal 17 because absolute value of 17 is 17. So 17 equals 17, so it would check out. 3, go ahead and write the two cases. Get rid of the absolute value for both of them. Here's case 1. We have b minus 1 equals 3. There's the positive. And we have b minus 1 equals negative 3. Go ahead and solve for b by adding 1 to both of those equations. Solve for b. And we find out the two possibilities are 4 and negative 2. So these would be my two options. And again, we would need to go ahead and graph these on the number line. My plot being at a positive 4, and we have negative 2, so those would be my two plots. I want you to go ahead, pause the video here, and work through example 4. Remember, rewrite it into two equations to solve to get case 1 and case 2, and then go ahead and graph on the number line. Case 1, case 2, there they are. Solve for y. By subtracting 2, we find out that y is 2 and negative 6, and then we'll want to go ahead and graph on a number line. Here's my number line, my possible solutions being negative 6. We'll put a plot, and a positive 2. There's our plot. Example 5 is a unique example. Reason why is, look here. Here's the absolute value. We have the absolute value of x minus 4 equals negative 2. This here is no solution. Reason why? You cannot have the absolute value of a number equal a negative number. Okay, you're not negative units. You're 5 units away, you're 10 units away. Doesn't matter if it's positive, negative. Kind of bringing you back to that first example where we had the absolute value of negative 5. Well, that is going to give us 5. The absolute value of 5 is going to be 5. So we can't have the absolute value of something be a negative number. That's why it is no solution here. And this will conclude absolute value solving equations day 1.